press the bell icon on the YouTube app and never miss another update.
Hello students, in the last class we discussed the sample space, okay, correct. Today we continue. So after knowing the sample space, that is very important, one more topic today we discuss, that is event. Also you know this one, okay. So once again we recall about the event concept. Event means in a probability, event means what? That's very important. So I write the sample space of throwing a die. Throwing a die. So I want to write the sample space. The sample space are total number of outcomes 5, 6. Throwing a die. Then I write one more subset such that I call it as A. It contains only the even number of the sample space. 2, 4, 6. No doubt A is a subset of yes. Correct? So if you want, I write one more subset, that means only the prime numbers. What are those prime numbers? 2, 3, 5. No doubt these also a subset of sample space, yes. Then I want to write one more set, only the odd numbers. So no doubt C is a subset of sample space. If you want one more set, I write D, such that it is a divisor of 6 or else divisor of 9, 3, 6. So then all these sets are called event. All these sets are called what? Event. Then what is the actual definition? Event means, so observe here, all these are all subset of what? Sample space. Then you know about the definition. Event means it is a subset of sample space. It is any subset with respect to the sample space are called event. Any subset, okay, any subset with respect to the sample space, any subset of a sample space or else with respect to the sample space are called what? Event. That is very important. In another way, if you want to say the favorable outcome, see, observe here my favorable outcome is only even numbers. Here my favorable outcomes is only prime numbers. Here my favorable outcomes is odd numbers, and here my favorable outcomes is divisor or means factor of 9. The favorable outcomes of a sample space, very important, the favorable outcomes of a sample space are called event. Okay, this is my definition. Okay, the favorable outcomes of a sample space are called event. Then what is the actual definition? If anyone want to say what is the actual definition of event? Event is a subset of what? Sample space. This is very important. Event is a subset of sample space. After knowing the concept of event, then we write event. So already you know in the previous class, it means first PUC, how to write the events. So after knowing the concept of event, so we discuss one by one types of events, because these are all very important with respect to the second PUC classes. Okay, types of events, First one is sure events, sure or impossible events. The second one is simple events, simple events. Third one is compound events, compound events. These three are the types of events, types of events, types of events. Sure events, impossible events. So one by one I want to say the example. So for that, throwing a die, we want to write the sample space. 2, 3, 4, 5, 6. Okay. 1, 2, 3, 4, 5, 6. Then I write the event A such that a number greater than 6. I want the number greater than 6. That means what? A is on empty. A is on empty. Then that event we call it as impossible events. If the event is empty, very important. If the event is empty, then that event we call it as what? Impossible events. The word says that impossible. No favorable outcomes exist. No favorable outcomes exist. Then that event we call it as impossible events. Suppose I want to write one more event B such that a set of numbers less than or equal to 6. Set of numbers, got my pointer? Set of numbers less than or equal to 6. That means B is exactly the sample space. B is equal to yes. B is equal to x. Then such events, if the event is equal to the sample space, that is very important. If the event is equal to the sample space, then that event we call it as what? Sure event. That event we call it as what? Sure events. If the event is equal to the sample space, then that event we call it as what? Sure events. Okay, then one more event. Suppose I want to write the event C such that a number less than or equal to 1, a number less than or equal to 1, then C is equal to only one element present. Got my point? Only one element present. Then that event we call it as what? Simple events. So in the set manner, if you want to say singleton set, a set contains only one element. A set contains only one element. Like what? Simple event means, got my point? A simple event means a event contains only one element. And that event we call it as what? What? Simple events. Okay. Then one more set I want to write regarding the D is equal to a numbers less than or equal to 3. Then D is equal to, what are those? 1, 2, 3. Then such events we call it as what? Compound events. More than one element present in an event. In an event, more than one elements are present are called what? Compound events. These are what? The types of event. That you know, types of events. After knowing the types of events, some operations are there. Some operations on two events. So number one is A or B, that is same as A union B. A or B, that is same as A union B. This means what? The elements which are present in A, either present in A or present in B, or both A and B. So A union B is nothing but A or B. That operation you know. A and B. That is exactly nothing but A intersection B. Common elements. So one more, A but not B. That is nothing but A minus B. The elements which are present in A but they are not present in B. Fourth one, A dash, complementary event. Okay, complementary event, that means that is exactly nothing but S minus A. That is exactly nothing but what? S minus. The elements which are present in the sample space but they are not present in the given event. Complementary events. So these four operations are called operations of events. A or B, A and B, A but not B, A dash. Okay, then after knowing this one, two more events are there. Very important events. Okay, two more events are there. So before I explain those two events, once again I write one example. What? Throwing a die. The sample space are 1, 2, 3, 4, 5, 6. Then I want to write two events, two favorable outcomes, two set of favorable outcomes. Number one is A is equal to, it contains only odd numbers. One more, the B is equal to, it contains only even numbers. One is the favorable outcome is odd numbers. Another one is the favorable outcome is only even numbers. So A union B, if I want to union those two events, that is nothing but what? The sample space. Yes, na? A union B is nothing but 1, 2, 3, 4, 5, 6. That is nothing but sample space. If I intersect A intersection B, that is nothing but what? Empty set. This we call it as mutually exhaustive events. And this we call it as mutually exclusive events. These two are very important. Mutually exhaustive events. If the union of the events is equal to the sample space, then those events are called mutually exhaustive events. Got my point? Union of the events are equal to what? The sample space. Union of the events are equal to what? The sample space. Then that we call it as mutually exhaustive events. If intersection of the event is equal to empty set, that is very important. If intersection of the events is equal to empty set, then those events are called mutually exclusive events. Intersection is empty, then we call it as mutually exclusive events. Union is sample space, then we call it as mutually exhaustive events. This is about this all things what I explained regarding event. This all these things you know. Okay, regarding event. Better we solve one problem, one simple problem. Then we go for next topic. One simple problem I take and I solve. Okay, then we go for next concept of the probability. Okay, so one simple problem. Simple problem, just simply observe here. A die is thrown. Describe the following events. Describe the following events. First one. A die is thrown, describe the following. So better I write the sample space. The sample space of the experiment is 1, 2, 3, 4, 5, 6. Total number of outcomes. All outcomes, if you write represent in a form of set, then that we call it as what? Sample space. The first event, first number 1, a number less than 7. A number less than 7. What are those? A is equal to, yes, all the elements, the sample space. Then this event we call it as what? Sure event. Second one. B. A number greater than 7. Then B is equal to what? Null element. Impossible events. First one is sure events, second one is impossible events. So third one, C. A multiple of 3. Multiple of 3. What are those elements? Only 3 and 6. Multiple of 3. Then D is equal to, fourth one, D is equal to a number less than 4. Then D is equal to, what are those? 1, 2, 3. Less than 4. Next, last fifth one, E is equal to an even number greater than 4. Then E is equal to only one element, that is 6. Correct? E is equal to only one element, that is what? 6. All these events. Okay. Then what he asked, first one is, one more, we continue this question. He asked A union B. A union B is nothing but what? The sample space. Correct? Either the elements which are present in A or in B, or both A and B. Then A intersection B. Common elements, since B is an empty, so A intersection B is what? A intersection B is empty. What my point? A intersection B is what? Empty. Next, A minus C. Okay. A minus C, it indicates what? The elements which are present in A, but they are not present in C. What are those elements? 1, 2, 4, 5. A minus C. 1, 2, 4, 5. A minus C. Then D minus E. D minus E. So the elements which are present in D, they are not in E. What are those elements? So D minus E. 1, 2, 3. Because it is nothing but D. D. Then one more problem, E dash. Simply I write E dash. E dash is nothing but complementary event S minus E. E dash is equal to what? S minus E. S minus E. The elements which are present in S, but they are not present in E. So what are those elements? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Got my point? I take a simple problem. Better what do you do? In the first PUC textbook, one exercise is there, how to write the events and how to write all these operations. Better to solve. Then only you perfect the concept of event. Because in the probability, sample space and events are the basic foundation. If you know very well how to write the sample space and how to write the event, then only it is very easy chapter, probability. That's why I explained all these things. Okay, so to perfect the concept, better those two exercises in the first PUC to solve very well. Then only you understand all the concept. Okay, so we will go for the next concept. Okay, after knowing the event concept, after knowing very well about the event concept, we go for the definition of the probability. The definition of probability. Now I entered probability. What is meant by probability? Or else define probability. Probability of an event, simply E is equal to, simple definition, you know very well that one also. Probability of an event E, if you want to write P of E, probability of an event E, so that I represent P of E is equal to total number of favorable outcomes, total number of favorable outcomes divided by total number of possible outcomes. Probability, very important definition. Now I define the probability of an event, any event that will represent P of E. Total number of favorable outcomes, total number of favorable outcomes, that means P of E is equal to favorable outcomes is nothing but what? Events, N of E. I write E, if I want to write A, N of E. E is represent E, event. Total number of favorable outcomes, that is N of E, divided by total number of possible outcomes. Possible outcomes is S, sample space, N of S. P of E, very important definition. P of E is equal to N of E divided by what? N of S. Total number of favorable outcomes divided by total number of outcomes. Then one more very important, P of E value greater than or equal to 0, less than or equal to 1. This is very important. Probability of any event value oscillate between 0 to 1. It must be greater than or equal to 0, not less than 0. And less than or equal to 1, not greater than 1. It oscillates between 0 to 1. Probability of any event, any event greater than or equal to 0, less than or equal to 1. This is what the definition of what? Probability. Probability of an event is equal to total number of favorable outcomes Total number of what? Favorable outcomes divided by total number of possible outcomes. Total number of possible outcome. In a simply manner, if you want to say P of E, that means probability of an event E is equal to N of E. Total number of events divided by total number of sample space, and P of E is always greater than or equal to 0, less than or equal to 1. So that value oscillates between what? 0 to 1, not less than 0, not greater than 1. It lies between 0 to 1. This is what the definition of what? Probability. The definition of probability. Better, what we do, we solve one problem regarding probability. Better we solve one problem regarding the simple problem. What? Throwing a die. The sample space are six. The sample space are 1, 2, 3, 4, 5, 6. In that, I want to write one event. Event A. Only what we do? Even number. Okay, even number. So then we write A. 2, 4, 6. Only the even number. 2, 4, 6. Then I want P of E. Here N of S 6, N of A 3, P of A, N of A divided by N of S, 3 by 6, 1 by 2. Correct? 3 divided by 6, the answer is what? 1 by 2. So if you want to write one more, no problem. What do we do? Prime numbers. Prime numbers. So prime numbers, that means B, 2, 3, 5. Then say what? P of B. N of B. N of B is what? N of B is equal to 3. 3 by 6, 1 by 2. 3 divided by 6, 1 by 2. Then C, if you want to see, what? Composite numbers. What are those composite numbers? 1 is not there, 2 is not there, 3 is not there, 4, yes, 5, no, 6. N of C. It is 2. Probability of C, 2 divided by 6. Answer is 1 by 3. Answer is 1 by 3. So I want to write one more D. What we do? Divisor of 4. Factor of 4. Factors of 4. Then what are those factors of 4? Or else factors of 2 I want to take. So 1 comma 2. Any number, factors of 4 if you want to take, okay, 1 comma 2. P of D, 2 by 6, it is 1 by 3. If you want, I write one more event, less than or equal to 6. Sphere lot comes less than or equal to 6. Then E is nothing but what? The sample space. is nothing but sample space P of E. 6 divided by 6 is equal to 1. 6 divided by 6 is equal to 1. So if you want F, one more event greater than 6, then F is equal to what? Empty. Then P of F 0 divided by 6. Answer is what? Answer is 0. So this is the way. Observe here, all the values oscillate between 0 to 1. That is very important. Not less than 0, not greater than 1. All the values are oscillate between 0 to 1. This is the method to find the probability. This is the method to find the probability of an event. Up to this is the first PUC concept. Up to this, we recall what we learn in the first PUC. Next, we go for second PUC concept. Okay, observe carefully. One by one, we discuss second PUC concept. Next, second PUC concept. Conditional probability. Conditional probability. Very important. Very simple concept. Conditional probability. So now I entered second PUC syllabus. Observe carefully. One by one topic we discuss. Okay, this is the first concept. This is the first one. Conditional probability. Conditional probability means what, sir? Observe here. Let A and B are the two events. A and B are the two events with respect to the same sample space. Yes, means these two events came from sample space S only, same sample space S. Then the probability of A, okay, given that B has already occurred. Given that B has already occurred means the probability of B is given. The probability of A given that B has already occurred is called conditional probability of A given B. Observe here. I explain in my sentence manner. If you want a standard definition, we will see later. Observe here. A and B are two events with respect to the same sample space. The probability of A given that B has already occurred. B has already occurred is called B has already occurred is called conditional probability of A given B, and denoted by P of A, write a bar B, read as P of A given B. This is the notation, conditional probability notation. See, observe here, the probability of A given that B has already occurred is called conditional probability of A given B. A given B denoted by P of A bar B, read as P of A given B or P of A given. What is the definition? P of A given B. Now I write the definition. This is just simply the knowing the concept. This is what the definition, P of A given B. So we read as P of A given B, P of A intersection B divided by P of B. This is what the definition. P of A given B, P of A given B is equal to P of A intersection B divided by P of B. So conditional probability of A given B, conditional probability of A given B, this is what the definition of conditional probability. Conditional probability of P of A given B is equal to P of A intersection B divided by P of B. Last given is what? B, that's why B. If you want conditional probability of B given A, observe here, B given A, it is same as P of A intersection B, because commutative A intersection B is same as B intersection A divided by P of A, divided by what? P of A. P of A intersection B divided by P of A. This is what the definition of conditional probability. These two events with respect to the same sample space. Then the probability of A, conditional probability concept means, this is what the concept. In my manner, the probability of A given that B has already occurred is called conditional probability of A given B, is called conditional probability of A given B denoted by P of A given B. Read as P of A given B, P of A given B. Definition, what is the definition? P of A given B in a simple manner, not at all complicated, very simple manner. Observe, the definition is P of A given B is equal to P of A intersection B divided by P of B. Here last B given is B, that's why B. If you want P of B given A, P of B given A is equal to P of A intersection B divided by P of A. This is what the definition of what? Conditional probability. So conditional probability, once again once again a simple manner I want to write. Conditional probability P of A given B, we read as, very important, P of A given B is equal to P of A intersection B divided by P of B. P of A intersection B divided by P of B, or P of B given A, P of B given A. If you want to write B intersection A, no problem, divided by P of A. This is what the definition of conditional probability. So these two, this is we read as P of A given B. This we read as P of B given A. P of B given A. P of A given B. P of A intersection B divided by P of B. P of B given A. P of B intersection A divided by P of A. This is what the definition of what? Conditional probability. Here P of B is not equal to 0. Very important. And here P of A is not equal to 0. Because if it is equal to 0, it is infinity. P of B is not equal to 0. Here P of A is not equal to 0. You know, denominator is equal to 0. What will happen? So we can read as P of A given B or A bar B. This one P of B given A or P of B bar A. This is what the definition. I think you are understanding the definition of conditional probability in a simple manner. P of A given B. P of A intersection B divided by P of B. P of B given A, P of B intersection A divided by P of A. Last letter B is there, B. Last letter A is there, A. A is there, A. So, better we solve some problems regarding conditional probability. Then only you perfect the concept. Formula you know, definition already know. We solve some problems regarding what? Conditional probability. First problem, exercise 13.1. First problem, given that E and F are events such that so he has given the values P of E 0.6, P of F 0.3, and one more he has given P of E intersection F 0.2. What he has? Find P of E given F and P of F given E. Simple problem, solution. Given P of E is equal to 0.6, P of F is equal to 0.3 and P of E intersection F is equal to 0.2. To find P of E given F and P of F given E. So by definition, one by one, P of E given F. So P of E intersection F divided by what? P of F. Substitute all the values. 0.2 divided by 0.3. So this one will runs 2 by 3. Write the answer. Next, one more. P of F given E. P of E intersection F divided by P of E. 0.2 divided by 0.6. 2 by 6. 1 by 3. That's all. 1 by 3. According to the definition, P of E given F, P of E intersection F divided by P of F. P of F given E, P of E intersection F divided by P of E. Got my point? Observe the problem. This is the first problem. Observe very carefully. Next problem. Second problem, compute P of A given B. If P of B 0.5, P of and P of A intersection B 0.32. Very simple problem. Very simple problem. Point P of A given B. By definition of conditional probability, A intersection B divided by P of B. Correct? So 0.32 divided by 0.5. That is I left to you. Calculate and write down the answer. 0.32 divided by 0.5. Next question. Third question. If P of A 0.8, P of B 0.5, find one more here is given and P of B given A 0.4. Find first one A intersection B. Second one P of A given B. Third one P of A union B. Third one P of A union B. One by one. We will see one by one. Very simple problem solution. Given P of A 0.8, P of B 0.5, P of B given A 0.4. Since means according to the definition of conditional probability, B given A is nothing but P of A intersection B divided by P of A. Correct? P of A intersection B divided by P of A. P of A intersection B is equal to P of A into P of B given A. P of A is what? 0.8, 0.4, 0.32. P of A intersection B 0.32. First one is over. P of A intersection B is 0.32. What about next question? Second one, right here. P of A given B. P of A given B. P of A intersection B divided by P of B. According to the definition. A intersection B 0.32 divided by P of B. P of B is what? 0.5. Calculate and find out the answer. 0.32 divided by 0.5. Third one. P of A union B. P of A union B. 32 by 5. Okay. If you multiply by, then you calculate and find out the answer. That is 3.2, not 32, 3.2 divided by 5. P of A union B. So for that, we know that in the first PUC class, we know in property, P of A plus P of B is always equal to P of A intersection B plus P of A union B. P P of A union B, P of A intersection B plus P of A union B. So here what we want? P of A union B. So that implies P of A union B is equal to P of A plus P of B minus P of A intersection B. Substitute all the values. P of A is what? 0.8 plus P of B is 0.5 minus 0.32. Calculate and write down the answer. That is I left to you. Add and subtract, final write down the answer. This is what the problem, third problem. We will go for the next problem. Next problem, fourth problem. Evaluate P of A union B if 2 into P of A is equal to P of B is equal to 5 by 13 and P of A given B is equal to 2 by 5. P of A given B is equal to what? 2 by 5. So that given 2 into P of A is equal to P of B. 2 into P of A is equal to P of B is equal to 5 by 13. That implies 2 into P of A 5 by 13, P of A 5 by 26 and P of B is what? 5 by 13. So since P of A given B is equal to 2 by 5, that implies P of A intersection B divided by P of B is equal to 2 by 5. Right here, that implies P of A intersection B is equal to 2 by 5 into P of B. Correct? 2 by 5 into P of B. 2 by 5 into P of B. P of B is what? 5 by 13. So P of A intersection B 2 by 13. P of A intersection B is what? 2 divided by 13. So okay, P of A is here, P of B is here, and P of A intersection B 2 by 13. He asks P of A union B. P of A union B. So P of A union B, since P of A union B is equal to P of A plus P of B minus P of A intersection B. P of A 5 by 26 plus P of B 5 by 13 minus 2 divided by 13. 2 divided by 13. Then so In these two terms, 26 is the LCM. 5 plus 10 minus 2 by 13. 15 by 26 minus 2 by 13. 26 is the LCM. 15 minus 4, I think. Yes. 11 divided by 26. 11 divided by 26. Observe the problem very carefully. So, very interesting problem, very simple problem. Okay, up to this we stop. We continue the remaining problems in the next class. Thank you.